Hi everyone, welcome to problem set P5 video key. All right, so we're going to start with number one here. We're going to start with this inequality, 5 is less than or equal to 10. And we're going to do these 8 different things that it tells us to do here. First, we're going to add 4 to both sides. So when you do that, we get 9 is less than or equal to 14. And then we're supposed to say if it's true or false. This is true. Subtract 12 from both sides, and you're going to get negative 7 is less than or equal to negative 2. Also true. Multiply both sides by 4, and you get 20 is less than or equal to 40. True. And divide both sides by 7, you get 5/7 is less than or equal to 10/7, which is true. Coming over here, add negative 4 to both sides, so you get 1 is less than or equal to 6, which is true. Subtract negative 12, which is the same thing as adding 12, so you get 17 is less than or equal to 22, which is true. Multiply both sides by negative 4, and you get negative 20 is less than or equal to negative 40. Whoops, that one's false. And divide both sides by negative 7, you get negative 5/7 is less than or equal to negative 10/7. That one might be harder to recognize, but that one's also false. You could type it on a calculator and change these to decimals if you wanted, or realize that this number would be bigger than negative 1. Well, like without the negative, it's bigger than 1, and then this is less than 1, so a negative number here would be like a bigger negative, we say, which means it's a smaller number overall. So that one's also false. B, what can you do to the false statements to make them true without changing the numbers? Change the direction of the inequality symbol. That's what we're looking for here. Change the direction of the inequality symbol. Okay, make a conjecture about performing operations on both sides of an inequality. Explain why this is necessary. So when you multiply or divide both sides by a negative number, you have to change the inequality symbol, which is what we did here. We multiplied by negative 4, we divided by negative 7. Both of those were false. So it creates false statements, so you have to switch the inequality symbol. So I'll write that out. When multiplying or dividing both sides of an inequality by a negative number, you must switch the direction of the inequality symbol. Okay. What does it mean to be a solution to an inequality? That is to be a value for the variable that makes the inequality true. A value for the variable that makes the inequality true. Just like we do with the equations. How many solutions does it have? Infinitely many. For example, x is greater than 4. Well, how many numbers are greater than 4? 5, 6, 7, 8, 9, 10, 11, 12, and all those numbers, and you just go on forever. All right, so let's talk about how we can solve these and then graph them on a number line. Looking at number 3 here. So starting with 5x plus 13 is less than negative 27. Just like with an equation, subtract 13. We get 5x is less than negative 40. Divide by 5. And you get x is less than negative 8. Now notice here, we did not divide by a negative. We divided both sides by 5. So it has to be this number that we chose to divide by. This was already a negative 40. We divided a negative number by a positive number. So we do not switch that. We did not divide by a negative. So we get x is less than negative 8. So on a number line, since it's just less than and not or equal to, we're going to put 3 numbers on here, one greater than this number, which is negative 7, one less than it. Since it's just less than and not or equal to, it's an open circle as opposed to filled in. If we had this, then we would fill it in like that. Okay, and then it goes, numbers less than -8 go this way forever. In interval notation, kind of the same thing. If we're going this way forever, the smallest number, there is no smallest number that we can equal. So we call that negative infinity. So in interval notation, it's just where we start, which is negative infinity, and then we have to end at -8, but not equal -8. So it's like going to be everything right up to -8, which like you can get infinitely close to that. So to represent that, we do a parenthesis. So a parenthesis is just like having an open circle here, is just like having just a less than or greater than symbol without the or equal to. So those all mean the same thing. And then on negative infinity, that's not even a number, it's more of a concept. So you can never actually equal negative infinity, and so that's always going to be a parenthesis. The other option would be, you could have something like this, negative infinity. If we could include -8, we would put a bracket. And the bracket means, like a square bracket, that means that means -8 is included, but that's not what's happening here. So that's interval notation. All right, so we're going to solve these and then put them on a number line and use interval notation. So first subtract 3. I'm going to distribute at the same time and get 8x plus 2. I already subtracted 3 in my head, so we get -6 over here. Subtract 2 and you get 8x is greater than -8. Divide by 8 and you get x is greater than 1. So with x being greater than 1, here's 1, 2, 3, whoops, that was terrible. 1, 2, 3, 0. And then start at 1. It's an open circle because it's just greater than, and numbers that are greater than 1 go this way. Okay, so there's your number line. And then interval notation, the smallest number we can be, if you look at this, is 1. So we start at 1, we go on forever, and then it's a parenthesis on 1 because it's just greater than, not, or equal to. Okay. Part B here, I'm going to add 5x and get 28x. Minus 21 is less than 9. Add 21 and get 28x is less than 30. And then divide by 28. Divide by, 28. Divide by 28, and you get x is less than, if you reduce, it's 15/14. So hopefully, on a number line, this one's kind of weird because it's a fraction, but the number line doesn't have to be like drawn to scale. So that's 15/14, which I know is bigger than 1. So I can just put 2 here and 1 over here. Again, the spacing isn't correct, but that doesn't matter to me. And then we can go starting with 15/14, numbers less than that, which are this way. So our number line looks like that. And then our interval notation is the smallest number is negative infinity, as we talked about earlier, and then up to 15/14, not equal to. On C, you can distribute first if you want, which is probably how most of you did it, so I'm actually going to show a different way. You could divide by -12 first. Okay, now since I divided by negative, I'm going to switch this thing. So I get -12 on this side when I divide, but then it has to become less than, and then on the other side, all we have is x plus 5, because the -12 canceled out. Then you can subtract 5 from both sides, and you get -17 is less than x. Now, I always recommend reading it the variable first. So if we read backwards, we go x and read it this way. So it's x is greater than -17. So when we go to make our number line, x is greater than -17. So here's -17, -16, -18. And then we start at -17, and the numbers greater go to the right. In interval notation, again, we're starting at -17. That's the smallest. Not or equal to, and it goes on forever to the right. So it's -17 to infinity. All right, if you hear my chair rolling around, it's because my lights keep turning off and I'm trying to turn them back on. All right, so D for the first time has an or equal to symbol here. So that's just going to change this to a filled in circle, and we'll change this to a bracket in our problem. So let's solve this one first, and then we'll figure that out. So let's see. Over here, this is really like having a -1. So imagine distributing a -1 there. So I'm doing nothing to this side. I'm distributing -1, so I get -3 plus 5x. And then we can combine like terms, giving us 11x minus 4. Something weird actually happens on this one. So we're not even going to get to illustrate the interval notation as I was hoping. And then you get 11x minus 3 over here. And now you can subtract 11x, but it cancels on both sides, and you get -4 is less than or equal to -3. So like in when we solve equations, when the variables cancel, are we left with a true statement or a false statement? Well, -3 is greater than -4. Since that's a true statement, then we have infinitely many solutions. Infinitely many solutions. And the way you represent that on a number line, it's kind of weird. You probably never do it, but you can just put any numbers on here. It doesn't matter. I'm just going to go 0, 1, and -1. And then infinitely many solutions, it just goes forever in both directions. Like every number works. And then in interval notation, every single number works. So you just say -infinity to infinity, every number. And that's what that looks like. All right, number 5, what is the difference in a problem when you have greater than or less than versus having greater than or equal to or less than or equal to? That's what I've already explained. It means you can equal the number that we have at the end. So like in this case, if this were or equal to, that means this number is a solution. And then that means this would fill in and this would be a bracket when you write those solutions. So it means the number we end up with can be used. So when using these, our key number, as I call it, like that number we end up with at the end, is a solution. It's a value that will work. All right, now we have compound inequalities. Not much different than what we were just doing, except we have two inequalities at once. Now, if we were to pretend like this wasn't here, and we just solve this, you subtract 9 from both sides. And then if this wasn't here, and you just solve this, you also subtract 9 from both sides. So we can do it all at the same time and just subtract 9 from all three places like this, giving us -2 is less than or equal to x is less than 3. And then to write this on a number line, so this is weirder than before, but we can just put -2 and 3 on here, what I call our key numbers. We can equal -2, so we put a filled in circle. We cannot equal 3. And then, if you read this just one at a time, here x has to be less than 3, so less than 3 is going to go this way. But at the same time, x is greater than -2, which has to go this way. And so they just go towards each other, and so those are the solutions. These numbers, all these numbers between -2 and 3, make this thing true. Like pick the number 1, for example. 1 is less than 3, and it's greater than -2 at the same time. So this is called an AND problem, because both things have to be true at the same time. As opposed to the next problem, that will be an OR problem. Our interval notation is the smallest number is -2, and we can equal -2, so it's a bracket. And the biggest number is 3, but you can't equal 3. So it looks like that. Okay, so that's called an AND problem, because they both occur at the same time. Like you can be less than 3 at the same time that you're greater than -2. In an OR problem, that's not going to happen. So OR problems are easy to identify because they have to have the word OR in them. So here we're going to subtract 9, and get -2 is greater than x. Or subtract 9, same step because I made it the same expression on that side, and you get x greater than or equal to 3. So now if you pick a number that's like greater than or equal to 3, like 5. 5, of course, is greater than 3, but 5 is not less than -2. So it works here, but it doesn't work here. That's why it's an or statement, because it works in one or the other. We're finding the solutions that works in one or the other, but not both at the same time, because there are no solutions that will work in both at the same time. So on a number line, this one's also kind of funky. Here's -2 and here's 3. Numbers greater than or equal to 3 go this way. But if we read x first, x is less than -2. Numbers less than -2 go that way. And so these point away from each other, whereas for an and problem, if you noticed, they went towards each other up here, right there. Okay, and then in interval notation, now this one's a little weird too. So from here, it goes 3 to infinity, like that. Oops, it's or equal to 3, so that's a bracket. And then here we go negative infinity, it goes forever this way, so negative infinity to -2. Oops, that's a -8. Negative infinity to -2, like that. And then what our solutions are is really like all of these combined. And so what we do is we put this little u in here, which stands for union. We're like uniting these two answers. So all of our solutions are either in here or they're in here. But it's nothing that is actually between 2 and 3. None of those numbers count, -2 and 3. Okay, number 7, why does number 6b have the word or in it, but number 6a does not? The solutions to 6b cannot occur at the same time, which I already explained. Okay. And then we just have some more examples of solving compound inequalities. And we got to do number line and interval notation. So this one subtracts 7, and you get x is greater than -1. Or, here we're going to subtract 8, x is less than -5. So you can't be greater than -1 and less than -5 at the same time. It's just not possible. So on a number line, here's -1, and we're greater than or equal to that, which goes this way. And then -5, less than that, which goes that way. Interval notation is going to be, let me change this color, it's all kind of blending together. There we go. Interval notation is, so we have -1 forever, and we go forever up to -5, so negative infinity to -5, not counting -5, and then that will be a union between those two things. Okay, and then on B, we subtract 3, and we can do this from all 3 spots, like this. And you get 6 is less than or equal to, or is less than 6x is less than 12, and then we can divide all 3 by 6 to get rid of this 6 right here. And you get 1 is less than x is less than 2. So now x is between two numbers, like it's literally between two numbers when you look at the way the solution is written. So here's 1, here's 2, you gotta be less than 2, which goes this way, but bigger than 1, which goes that way. So those occur at the same time. So our solutions look like that. And that's where our interval notation is just between two numbers, so it's going to be from 1 to 2. And neither of those solutions are included. So it's parentheses, not brackets. All right, now this one says the word and. So you can say the word and. It's not usually written, but it is in this case. So let's subtract 3 and get 2x is greater than -12. Divide by 6. Divide by 2. I was thinking the answer ahead. And you get x is greater than -6. Over here we add 2. 8x is less than 32. Divide by 8 and you get x is less than 4. So we don't normally write the word and, but we will here because both of these can happen at the same time. You can be less than 4 and greater than -6. So that's where our number line solution, -6, 4, greater than -6, less than 4, so they go towards each other like that. And then in interval notation, that's just where you put those two numbers, and they're both parentheses because it's not or equal to. And finally, D, we have, if you multiply, so here we got to multiply everything by -2. So we have to switch the inequality symbols. So I'm going to write that. It'll be easier to write it than show it, I think. Multiply all by -2. Therefore, switch the direction of the inequality symbols. And that's exciting, so I'm putting an exclamation mark afterwards. All right, so after I multiply everything by -2, I get 10. Now instead of that, it's going to be the other way, greater than or equal to 12 minus x, and then greater than 4. Okay, then we subtract 12. Something crazy is going to happen here. Subtract 12 from everywhere, and you get -2 is greater than or equal to -x is greater than -8. But now, divide by -1. I'll write this out again. So switch again. Crazy. Okay, we divide everything by -1. Draw an arrow, we're going over here now. Divide everything by -1, and you get 2 is less than or equal to x is less than 8. And there we go, we got x by itself on a number line. Here's 2, here's 8, equal to, not equal to. So we have that, and then in interval notation, start at 2, you can equal to, and you go up to 8, not equal to 8. And there you have it. Yay.